Good morning, friends. Today we are going to learn about broadcasting in numpy. I created an array A having items 1, 2, 3, 4, 5, 6. Then I created an array B having items 7, 8, 9, 10, 11, 12, 13, 14. And if I perform operation A plus B, right? Since A has 6 items, so the shape will be 6 comma, right? And B has 8 items in it, so the shape will be 8 comma. If I perform operation A plus B, then since A has how many items? 6 items, so the shape will be 6. If the item B has 8 items, so the shape will be 8. Then if I perform A plus B, then it will throw error, and that error is a value error, and the value error says that operands could not be broadcast together with shapes. So in this case we took 6 items and 8 items, so the shapes are 6 comma and 8 comma, and if the shapes are different we cannot perform any arithmetic operation, right? So from this we can conclude that a broadcasting is a mechanism that allows numpy to perform operations on arrays of different shapes. And there is one solution regarding this problem, and the solution is broadcasting. So the note point is, if the dimensions are not compatible, you will get a value error, right? Till now we discussed about the broadcasting and its details. Now let us do practically. Okay. Now let us create array, import numpy as np dot array 1 comma 2 comma 3 comma 4 comma 5 comma 6, and let's name this as A. Now I am creating another array, np dot array 7 comma 8 comma 9 comma 1 comma 2 comma 7 comma 8. Okay. Now if I perform arithmetic operation on this, so since the shape of this is six comma, and here the shape is one, 2, 3, 4, 5, 6, 7. So 7 comma, right? Now when I perform arithmetic operation, it will throw a value error saying that operands could not be broadcasted together with shapes 6 comma and 7 comma, like this, right? Now so that's why the shapes should be compatible, that means they should be same. Now what is broadcasting then? So if I multiply vector with a scalar, let us say if I create an array, so I have information in kilometers, let us say in kilometers. Okay, so np dot array array of 1, 2, 3, 4, 5. Now I have information in kilometers. So 1 represents 1 kilometer, 2 represents 2, 3, 4, 5 kilometers. So if I want to change this into meters, so MTS equal to kilometers into 1000, right? Now print meters. So the meters array is having now 1000 meters, 2000 meters, 3000 meters, 4000 meters and 5000 meters. Now the numpy understood that this 1000 should be multiplied with each of the item. So 1000 is multiplied with 1, it resulted in, okay, see, 1 is multiplied with 1000, it resulted in 1000, okay. 2 into 1000, 2000, 3 into 1000, 3000, 4 into 1000, 4000, 5 into 1000, 5000. So KMS multiplied by 1000 means the items in KMS are 1, 2, 3, 4, 5. So each of the item is multiplied with 1000. So this is called broadcasting. Broadcasting is a mechanism which allows you to perform arithmetic operation even though the shapes are different. Now see, if I find the shape of this KMS, okay, and be let us find the dimensions here. KMS dot endim. What is this? 1. And what is MTS dot endim? 1. So here the compatibility is there, so we can, this is valid, so that is why this is valid. So numpy understood that each item of the KMS array should be multiplied with 1000. So this is called, this mechanism is called broadcasting. Okay, now let's visualize this above code. Now what we have written now, so I have written an array KMS. The items are 1, 2, 3, 4 and 5. See, the items are 1, 2, 3, 4, 5 and it is multiplied by 1000 and the resultant array is MTS, that is meters. When KMS is multiplied with 1000, that means 1 is multiplied with 1000 resulted in 1000 and 2 is multiplied with 1000 resulted in 2000 and 3 is multiplied with 1000 resulted in 3000. 4 is multiplied with 1000 resulted in 4000. 5 is multiplied with 1000 resulted in 5000. So if you give information in kilometers, now it's changing as meters because we are multiplying with 1000. So each item is multiplied. So even though this KMS and this is a vector and this is a scalar, when we multiply with vector and scalar, see, these have a definite direction and this is a numerous point. So when we multiply with a vector and a scalar, then the resultant will be a vector, right? In the same way, this broadcasting works. So this is about broadcasting in NumPy.